Hello, guys. How are you? Okay, great. So, welcome to our discussion. And today we are going to be looking at how to obtain the gradient function or the first derivative from first principles. You see, so let's recall that when we talk about the gradient function, I hope by now we now know that we're actually referring to something known as the first derivative. And we want to learn now how to find this uh, gradient function from first principles. So already we have stated in our previous lesson that finding a derivative or the gradient function from first principles simply means finding the derivative from this limit definition. So we now know that, yes, every time when you come across a question which says, can you obtain this gradient function of this particular function from first principles, then you have to make use of this definition to obtain that first derivative. So that's what we are going to learn at this point in time. See, so to understand how this works, we are going to look at different examples on how to do this. So the first example that we are going to look at, it goes as follows. So given that f of x is equals to x squared, find f prime of x from first principles. You see, so we want to see how can one find the gradient function of this function given from first principles. So to go about answering that, we already know that this thing that we want to calculate, it is given by f prime x is the limit as h approaches 0 of f of x plus h minus f of x over h, where h is an element of real numbers and h is not equal to 0, like that. So that's what we want to do now, to find the gradient from this definition. So now to proceed, we see that there are certain things that we have to know first in order to use that definition. And the first of that is to find f of x plus h. So what is f of x plus h? F of x plus h is a function which is obtained by replacing x in f of x by x plus h. So to do that, we get x plus h, then squared. And then when we expand that, we get x squared plus 2xh plus h squared, like that. You see. Then we see that in the definition also we need a difference between these two functions of f of x plus h minus f of x. And we see that this is just x squared plus 2xh plus h squared, then minus x squared. And we see that simplifies to h bracket 2x plus h, like that. Then now we can then put this into the definition. So if we take this and plug it into the definition, what do we have? So therefore we can see now that f prime of x is just the limit as h approaches 0 of f of x plus h, which is that over h. Then we can see now that from here, these two guys cancel, and what remains is just the limit as h approaches 0 to 2x plus h. Then we now know that from our understanding of how to evaluate limits, we know that when our function has been simplified to that manner, the next thing that we do is we replace h with 0, and then the final answer is just 2x. So this gives us the gradient function for that function. So this is how one obtains the derivative from first principles. It's a matter of finding the ingredients of that limit definition and then evaluating the limit, and that's all. So to provide another demo on another different function, let's consider another different example again. So another different example, it goes as follows. So given that g of x is equals to root x. Find g prime x from first principles. So again, we have that. And we want to know how can you find then the derivative of this function from first principles. So just like what we did previously, we're going to follow the same lines of reasoning. So already we know that f prime of x that we're trying to calculate is given by the limit as h approaches 0 of f of x plus h minus f of x all over h, such that h is an element of real numbers and h is not equal to 0. So now what is f of x plus h? So we know that to find f of x plus h, what we do is we go back to g, but now we're talking about g anyway. So we are actually calculating g of x plus h. So we are calculating g of x plus h. So what is g of x plus h? We see that g of x is just root of x plus h. So now this implies what is g of x plus h minus g of x. This is just none other than x plus h minus root x. So now what we do is we then plug this into the formula. So according to the formula, what do we have now? So therefore, the thing that we're looking for, which is g prime of x now, is just the limit as h approaches 0 of g of x plus h minus gx, which is just root of x plus h minus root x all over h, like that. So now we have to evaluate that limit. Now we see that already I can't evaluate the limit already, because when I try to plug in h equals to 0, everything that I have will become undefined. So the trick to deal with something like this is to actually check the conjugate of the top expression and multiply with it both in the numerator and denominator. So if I have x plus h minus root x, then I know that the conjugate of this function is actually root of x plus h plus root of x. Then I multiply with it in the numerator and in the denominator, and I obtain this. Then the next thing at the top, I simplify. So if you take the top and then simplify it, you will see that actually this resembles an expression that you only find when you factorize the difference of two squares. So if we were to reverse that, this will reverse to become x plus h squared minus root x squared all over h, then root of x plus h plus root x, like that. But we know that when we square the root signs, what is going to follow from that is we are going to have x plus h, then subtracting x over h, root of x plus h plus root x. Then what do we get? So what we get now is the limit as h approaches 0 of what? So now we see the x and x cancel, so we remove an h at the top, but that h at the top is going to be cancelled, the one at the bottom, so we just remain with 1 over root of x plus h plus root of x. So we plug in now, what do we call this? So now we plug in h equals to 0 on this, and we see that finally we get 1 over 2 root x. So that's exactly the derivative of this function from first principles. So this is how we obtain the derivative of functions from first principles, you see. But let's do one last example on something a little bit different. So at times you can be given maybe something like this. So given that f of x is equals to sine x, find f prime of x from first principles. So how can we calculate this from first principles? So the answer to this, it goes as follows. So already we now know the ingredients. So we have what? So first thing I'll find f of x plus h. So what is f of x plus h? It is just sine of x plus h minus sine of x. Easy. But now, what do we know? Now we can find the difference of f of x plus h minus f of x. So what is the difference? So we see now that if I were to, so sorry, actually I messed up here. This f of x plus h is that. Then what I have to do now to find the difference, that's when I get sine of x plus h minus sine of x. So it gives me that expression there. So this expression, if we use the expansion of sine x a plus b, we see that this becomes sine x cos h plus cos x sine h minus sine x. So that's what we get there. Then if I group together terms with sine x, what I get is I have cos h minus 1 sine x, then plus sine h cos h. So now we have that. Then the next thing that we can do now is we can now plug into the formula. So therefore now what is f prime of x? So we know that this is the limit as h approaches 0 of what? Of these two guys. So of cos h minus 1 sine x plus sine h cos x all over h, like that. You see. Then, since sine x and since cos h minus 1 over h and sine h over h, we know what these limits do. If we use the limit properties, this becomes simple sine of x times the limit as h approaches. So sine x, since the limit is being evaluated when h is varying, sine x is a constant, so we can pull it out of the limit, and then we just remain with the limit of cos h minus 1 over h. Then, and also that other side, cos x is a constant, so I pull it out, and then I remain with the limit as h approaches 0 of sine h over h, like that. You see. So if you look at this limit here, one of the things that you can see is that if you evaluate the limit of top and bottom functions, they are both 0 as h approaches 0. So which means at this point in time here, for this function, you are going to apply a rule, the familiar L'Hopital's rule. So you're going to apply the L'Hopital's rule. So when you apply the L'Hopital's rule that side, you will get sine x times the limit as h approaches 0 of minus sine h, then plus cos x times the limit as h approaches 0 of sine h over h. So we see now that for the first part, the limit as h approaches 0 is 0, so that whole part vanishes. And the limit of sine h over h as h approaches 0 is 1. This is a non-identity. So which means finally we have cos x. You see. So we can see therefore that f prime of x is equals to cos x, when f of x is just equal to sine x, like that. So yeah, this is how we evaluate derivatives from first principles. So yeah, we are going to end it here today. So thanks for watching. If you like the videos, put a comment, or if you have any recommendation as well, we'd like to hear from you how we can improve these lessons. Otherwise,